Okay. Well, I think we've got most of the people we need to get the meeting started. Sarah may join us in progress. I hope that she does. And she usually joins in any case, so we'll welcome her when she does. But I'm Al Morton. I'm one of the co-chairs of Benchmarking Methodology Working Group. I've currently got a paralyzed vocal cord, which makes me sound a little different than usual. But there's no problem with my trying to speak at this point. It just sounds funny, and it takes a little more effort than usual. So anyway, we'll take it ahead here. I see Sarah joining us now. So today, as I mentioned a few moments ago, Warren will be our in the room chairman, and sort out anything that we can't quite deal with remotely. But then thank you very much for standing in for the both of us again today, Warren.
No thing.
So it sounds like the mic level is kind of low from the meeting room. I didn't quite hear what you said, Warren.
Oh, I just said no worries.
Oh, okay, thanks. And I've turned up my volume here too, so that'll be good. Thanks. All right, so let's see. If you're currently not subscribed to the Bmwg mailing list, we've got the link right here where you can do that. And it's only Tuesday, so we'll take a quick look at the node well as we get going. So first off, we work as individuals. We try to be nice to each other, and that works pretty well. Also at this meeting, we want everybody to wear their mask unless they're up front presenting at the podium or at the microphone up front. And that's just safety for all of us. So in any case, I'm not showing video at the moment. I want to concentrate on my audio, but at some point I'll open that up. In any case, so the node well is a reminder that, you know, by participating here, you have to follow IETF processes, and the contributions are, you know, anything that happens here in the room, talking in the chat, talking at the mics. Those are contributions, slides, comments on the slides, and so forth. And if you have any questions about these, the policies, there's a long list of BCPs here that you can look at, or you know, you can ask me or Sarah or Warren. And basically it comes down to, you know, kind of like I said, we're trying to get everything covered here. So there it is. All right. So we've got 14 folks with us now. I'm going to go on to slide 3. So this is our agenda. If there's anybody in the room who wants to help out with the note taker position, that would be greatly appreciated. We're using the hedge doc notes, and so far I only see myself online in there, but anybody can join in and help us type in some notes that will help out with the preparation of the minutes. So if there's anyone who volunteers specifically, just sort of raise your hand and let us know. Nobody yet. So okay, but feel free to join in as we do this. And so here's our agenda. By the way, Jabber's built into the Meteco tool now, and we've already talked about IPR, so we're in good shape. So Warren's going to talk to us for a few seconds on the ops area director role. we'll do the status of the working group. We'll talk about the working group drafts, the standing working group adoption of one draft, the stateful NAT XY gateways. We've got a couple of good proposal drafts that have been submitted, and under all other business, there's actually been some progress on a couple of drafts that we've talked about before. I just want to bring that up to people's attention when we get done today. So any bashing needed to the agenda? Okay. All right, very good. So in the room, make sure you're using the mobile Meetecho tool to request your access to the floor mic, and that way we'll also see you as a participant and so forth. That will be good. Okay. So Warren's looking at the agenda. I think you can get up now, Warren, and do your thing.
Okay. Yep. My thing's really short. Basically, it's hi everyone. I'm currently Ops AD. I've been doing this for a while now. My role is up at beginning of March, end of March, something like that. I'm still enjoying it, so I will probably run again, but I would also be really happy if there are some other candidates, so the community can actually make a choice this time. So if anybody's interested in finding out more about the role or might be willing to serve, it is actually a lot of fun. Please let me know, come and chat with me at some time during the meeting, and I'm happy to explain what the role is actually like, what the time investment is, etc. So that's it, and back to Elwin's. Sarah.
That's great, thanks. Warren, one thing that has sort of come up, which it's been kind of a question for some of our newer participants, and basically I think all of our current participants who have drafts in the working group or nearing completion may not be familiar with your role when a draft comes up for the final review in front of the IESG. Would you like to say a few words about that?
Sure. So, I mean, one of the main things that takes time is the area director is supposed to review all documents coming out of the working groups in their area and pay specific attention. Sort of, is the document complete? Check the Shepherd write-up, etc. And then actually progress it through the IESG. So there's the ISG eval where all of the ADs sort of review the document and comment. Another large portion of it is actually the ISG reviews all documents which get progressed. So basically any document which moves from a internet draft to becoming an RFC, ADs sort of have to review them all, paying particular attention to conflicts in their area and also sort of general quality, has process been followed, etc. And then there's also sort of for the ops area, managing around 7 working groups: Bmwg, DNS op, CIDR ops, etc. So sort of the role requires a fair bit of review, but also quite a lot of breadth of knowledge. DNS, a little bit of benchmarking, routing, etc. Did that actually cover what you asked? The audio is not great, so I missed some of the question.
Oh yeah, sorry. Basically, when comments come in from the other area directors, you take a role in helping us getting those resolved, and I wondered if you wanted to say a word about that.
Yes, I do. I must admit, for Bmwg, I have not been taking nearly as active a role as Brian might be able to attest to. But I mean, yeah, a reasonable amount of it is also sort of after IESG eval, if there are any discusses on the document. Part of it is sort of helping guide the document through the last part, although there is also the responsibility of the document shepherd. But yeah, so having knowledge in benchmarking and DNS and CIDR ops and IoT would be very helpful. Is that what you were asking?
Yeah, and
Okay.
Lauren, I really wanted to thank you for all your time as an area director working with BMWG. I really appreciated that when you first took the this area director role on and as our advisor, you started to dabble in some benchmarking to get your feet wet in it, and that was I thought really useful. So thanks for the time you've spent so far, and obviously we'd really like to have you back, but that's yet to be decided. So in any case, um, keep reviewing and keep calm. Thanks. All right. So on to the rest of the working group status. So next generation firewall benchmarking is um, been in the IESG review since February. Still trying to resolve 4 discussed ballots plus the comments. We got a request for transport area review again. And the good news is a lot of that's coming together in the context of this meeting and in the email exchanges in between the March and the February meeting. So, I think that Brian's going to say some more about that, but it looks like we're pointed in the right direction there. We can expect a large rewrite for the multiple loss ratio search from Masiek and Bradco. We did finally get the Yang model for benchmarking adopted. We're going to try to close out on working group adoption for the Stateful-NAT XY gateways today, and proposals keep coming. So that means keep reviewing. If you've got proposals, learn by reviewing the stuff that we've already got going, and that will be a good background for you to learn about what we're doing and what we expect in the proposals that are successful here. So just general advice to all of our folks. No RFCs in the last period. Our charter's been very stable, and we've got this supplementary page that people can go check out. Thanks to Sarah and company for providing it. So I've gone in and looked at the milestones and updated them, and so we've got these new ones. I really shouldn't have made them in red, but I've updated the dates here for a few of them. And there's one that's marked done, which, it's basically done since the last meeting. We still need to do the publication part of it. But this first one here is at least made it to IESG review, and that's a good thing. The other ones on our list are done. And these others have been revised. So we'll probably be adding the Yang model I see is satisfying this one, the draft on selecting and applying models for benchmarking. And then the other ones we'll need to take a look at whether we have something ready to go or not. So anyway, that's where we stand on milestones. And in the backup, I just include this standard paragraph that helps us get through security reviews. And I think that's pretty much it. So any questions on the working group status? Okay. All right. So seeing none, we'll move on to the working group drafts. And for that, let's see here. So we've got a couple of topics today where we don't have slides. And what that means is I'm going to share my screen somehow. Here it goes. Oh, okay, I got to ditch this. And then I can do this. Yes. Oh, really? Okay. Let's try it again. Yes. Screen one. So, can everybody, yeah, I guess you can see the, wow, okay. So everybody can see the Miteco notes and the draft on multiple loss ratio search. We had a detailed update from Veratco, one of the co-authors, and I've got the link pointing to that on the mail list. Basically, they've continued just a larger rewrite of the draft. Lots of earlier material's been commented out, and one of the questions they've been asking, which I highlighted in my response on the list, was the ability of the authors who are basically trying to do more work than um, the typical benchmarking here. Uh, they're the typical throughput, RFC 2544 throughput, is it's basically a zero loss level of throughput. So they're trying to measure throughput at multiple levels of loss. That's why the name for the draft is multiple loss ratio search. And when they're doing that, they're encountering sort of some interesting um, problems with sort of partial support from the current definitions, and, complete support from the current definitions, and so forth. And I kind of think that at least when they measure the zero loss ratio, which is usually part of the set, that should be a full loss case and with full support. And then kind of like what they do beyond that is uh, sort of the best they can do, I guess. But if anyone else has read the draft, anyone else has looked at the email and considered the questions, now would be a good time to add some comments. All right. So if anybody has read the drafts, please let us know somehow. Okay. So, well then, I encourage the folks in the room to sort of reach out, help the authors a little bit. You'll probably see the co-chairs do that, and they can make some time. And it's up for us as a work group to work together and move all the drafts forward. The main thing in that is that helps us open up some slots for new work. So if you're trying to get something accomplished here, um, help the other folks out, and I'm sure it'll be reciprocated. That's the way it's always worked here. So in any case, thanks for that, and thanks for your future uh, collaboration. All right. So the next topic is, which we also don't have any slides for, is benchmarking. And by the way, I'm not really criticizing on this. It's perfectly fine that we have discussions on these topics. And, the information on the security device performance has been coming in pretty rapidly in recent days. So I'd like to invite um, Brian Monkman up to the front to give us a status, let us know how the side meetings have been going, and um, whatever you want to tell us about this would be good, Brian.
Sure. Thanks, Al. So we plan to post a new draft within the next 2 or 3 weeks, but there's been a lot of work that's been going on behind the scenes since the last IETF. As you mentioned earlier, we've been working with Tommy Pauly, who is helping us sort of expand the draft to cover off Quick and HTTP3 in a lot more detail. And I think we're making some good headway in that area. You mentioned the 4 discuss comments. We've addressed all of that with the exception of the comments that Lars put out, and we're dealing with Tommy to help address those. There was also some comments that were made previously about all of the shoulds that we had in there, and we've identified a significant number of the shoulds that we're going to change to musts, or that will expand the text on it to explain why it's a should. That will not be in the upcoming draft, because we wanted to get all of the major points out the door and get the area directors taking a look at it. But once we get approval of the changes that we made with all of the discussed points, then we will do the shoulds, and should be at that point, no pun intended. Yeah, it will be ready for to move forward, in my opinion. And a shout out to Warren. Thank you very much for getting the area directors to jump back on this as well. Anyone have any questions? All right, that's my update, Al.
That's great, Brian. Let me see. I'm trying to think if I have any specific questions. Do you have enough material you need to put in some default values for the like, for example, the window sizes and things for the other protocols that are mentioned in the draft? But as you mentioned to me, the test equipment currently doesn't implement Quick, for example. I mean, that Quick came in as a response to a comment. So we're open looking for help in that regard.
Well, the test equipment does implement Quick, but they may not implement it as per the standard, since the standard was only about I think it was only ratified about a month or so back. But we are definitely looking at various references to address things along the lines of what you suggested, and some decent reference sites that we've got links to.
Okay.
Our goal
Good.
here is, of course, to provide the level of detail I think that'll satisfy the folks in the transport area.
Yeah. Did Tommy know of any of these off the top of his head?
No, I don't believe he did, but I did take it as an action that I would forward him those sites, so he would have an opportunity to take a look at it. And I'm also thinking about how we can reference those sites within the draft, which is a question that I'm going to talk to you about.
Good. Okay. All right. That was the stuff in my mind. Any other questions for Brian?
I guess just a small apology from me that I haven't been more active on this. Some of the thread fell off the bottom of my mailbox, and I'd assumed that things were happening. Obviously, feel free to poke me hard if you need attention.
Yeah, I can be a pain in the butt.
Excellent. That's what we like.
Thank you, Warren. No worries. So, okay. So I've got good news on the Yang data model. We finally adopted that as a working group draft. I think that Vladimir is in the virtual room with us, and at least, or maybe in the room in real life. But maybe you'd like to say a few words about this, Vladimir.
Hi.
Hi, yeah, we can hear you, Vlad.
you able to hear me?
Yeah.
Yeah,
Let's see.
hey,
Oh,
I appreciate the quick response, Vladimir, to the comments that I left on the list. And I didn't mean to imply that we had to have a Yang doctor's review so early, but it's really good to do because the way it's written, you set it up at the top of the document and then immediately get into the Yang. And so just getting extra eyeballs on that earlier is always a good idea. But I appreciated the easy read of that and the quick response to the comments. If any of you are interested in the room and haven't taken a look at this draft, it's a really approachable draft. If it's your first time to BMWG and you have any Yang experience, it's a really great draft to take a look at. As Al mentioned, as you bring drafts into the group, part of how you get other reviews is by doing the same for other folks. So this is a really good one to start with if you haven't read it yet, or if you have any interest in at all in the Yang model he's laid out there.
great. Thank you, Sarah. And Vlad, I accidentally revoked your audio because I couldn't hear anything. So if you want to request audio again, I thought we heard you just for a second.
Oh, can you hear me now?
Yes, we can.
Okay, good. Yes, I agree with Sarah, and it's very important if we can find members that are interested in the draft, and especially young doctor review will help. We will get at least one more young specialist to have his eyes on that. And we're looking to some use cases like this implementation that I have for running code that we can use with some third parties and members of the IETF which are interested in trying it out, seeing how it its usability, and if they have their own use cases for the draft which we can support, eventually add to the discussion. This would also help the document. So anyone who can help in a way of finding people that can be critical for the text and the draft and have applications that can benefit from such a draft, we should try to kind of get their attention to the working group and start from there.
Great. By the way, Vladimir, how did the hackathon go?
Well, I am going to publish a presentation, which always comes later than the deadline for presentations. So I'm going to send a link to the mailing list, and it's mostly trying to add the multi-stream implementation working and trying it out. And the funny thing is, one needs the multi-stream implementation for the last two test points in the RFC, which is the reset test and the recovery test. There you have to have two different streams that at some point change the type of packets that are being sent. And that's what I was working for. But details will be sent on the mailing list.
Great.
Yes, I really have nothing more to add. If there are any questions, someone who is interested in the draft can answer that.
Okay. Well, thanks for your work on this and your flexibility on the titling of the draft, especially Vladimir. Appreciate it. So anyway, congratulations on working group adoption, and we want to see this through now. So let's get some reviewers on it. Does anybody volunteer to review the draft today? I don't see any hands, but also the camera on the audience is a pretty tight angle. So in any case, thanks for your work, Vladimir. All right.
Thank you.
So the next topic is really closing out a working group adoption review, and there's kind of a long history here for the benchmarking methodology for stateful NAT XY gateways. So long before the adoption, we had lots of people supporting and commenting on the draft all through this sort of same period last year. And there's been lots of improvements to the draft. Also, a couple of 3 people have replied to the most recent call for adoption. And so let's turn it over to Gabor, who's going to be speaking today on the draft. Gabor, I'm going to show the slides from here after I figure out the right ways to do this.
I hope that you can hear me well. Can you hear me well?
Yes, yeah, we can hear you just fine.
Okay, so I'm waiting to see my slides. If you can share.
Yeah, I know, I'm getting there. Don't worry.
So I
Okay.
can start now. Thank you. So we already mentioned the title of our draft. It's a bit lengthy, but I think every word is important because we would like to provide a methodology for benchmarking the stateful NAT XY gateways. XY means X and Y both may be 4 and 6. So NAT 44, NAT 64, and even NAT 66 could be the gateway. And it is important that we are using RFC 4814 pseudo-random port numbers, not fixed port numbers, but pseudo-random port numbers. Could you go to the next slide? So the aim of our proposal is to provide a methodology how we can benchmark stateful NAT XY gateways to measure their standard performance metrics defined by RFC 2544, RFC 5180, or RFC 8219, like throughput, latency, frame loss rate, packet delay variation, inter-packet derivation, and so on. And of course, the target is that these are stateful NAT XY gateways, not just routers or bridges. And of course, because they're stateful, they not only have to solve how to measure these metrics, but there are some metrics which are specific to stateful testing. For example, they define maximum connection establishment rate measurement and connection teardown rate measurement for last time. And now the new thing is the connection tracking table capacity measurement, which are included in this today's slides. And of course, we have to use these pseudo-random port numbers. Could you go to the next slide, please? It will be about the history. Yes, it is about the history. So it was presented first at IETF114, was the framework and the basic methodology. And the next time we defined the measurement of the connection tracking table to make clear measurements. And last time was the connection teardown rate measurement method. And now there comes 2 methods, the validation of connection establishment, and the next method, which uses this one heavily, is the connection tracking table capacity measurement method. And with this, I hope that the most important things will be completed. So could you go to the next slide? So these slides, there are a few slides which are reminders, of course, reminder for those who have already heard about it. And if you haven't been present in the past IETF meetings, then it may be a new thing. So let me just summarize the parts which have already been presented before. So test setup is very simple. It's familiar for all of you because we have one tester and one device under test. But unlike with router testing, now we have on the one side, the left side, private IP version for addresses and public IP version for addresses on the right side. and the two ports of the test are called initiator and responder. This is their role. So initiator may initiate a new connection through the stateful device under test, which is, let's say, an NAT44 gateway now, because we now use IP version 4 addresses for simplicity, but it works the same for 6.4 and other solutions. So the initiator just uses some port ranges and sends frames through the stateful device under test device. And when they are translated and arrive back to the responder stores the four tuples. I mean, source IP address, destination IP address, source port number, destination port number to the state table. And using these four tuples, of course, changes source and destination, it may send traffic back through the stateful NAT XY gateway, because otherwise it couldn't be done, because it would just drop the test frames which do not belong to any existing connection. And of course, when a connection is initiated, it is stored in a connection table with regards on the test. And which connections exist in there, those can be used in the reverse direction. Could you go to the next slide? Yes. And the measurement is done in two phases. So the new thing is the preliminary test phase, which serves two purposes. Of course, we have to fill the device under test connection table, and also they have to fill in the state table of the responder, which has four tuples, because from the very first second of the test, it has to be able to send frames in the reverse direction. I mean, from the responder to the initiator, also because we would like to use bidirectional traffic. And of course, this preliminary phase must always precede the real test phase, but in itself, preliminary phase can be used for measuring maximum connection establishment rate. And if we would like to perform a traditional test like throughput, frame of rate, latency, packet derivation, or inter-packet derivation, it is done in the real test phase, which has been preceded by the preliminary test phase. And they can be done as usual. Could you go to the next slide? Yes, thank you. And of course, we would like to achieve repeatable and meaningful results. So we would like to achieve two extreme situations. One of the situation is when every test frame creates a new connection. It is ideal for measuring the maximum connection establishment rate because it is only that. It is also necessary for the other measurements in the preliminary phase that we have to fill in the device and the test connection tracking table and the tester's state table. So it is necessary then. And then in the second phase, in the real test phase, the frame should not create any new connection. So for this reason, we can perform the other tests, just like throughput, latency, frame of rate, etc. in the second phase. And of course, to be able to achieve these clear conditions, we have to use the following three things below. We need to have a large enough and empty connection table before each test. And we use several random enumeration of all possible port number combinations in the primary phase. And we use a properly high time out value in the device of the test. It means that the time out value must be larger than the length of the primary phase and the delay between the two phases and the length of the real test phase. Then the connection is not time out. So could you go to the next slide? So it was really the reminder so far, and now comes the new thing. We also repeat the measurement methods for the maximum connection establishment rate because we would like to refine it. Of course, it's very simple. In the primary phase, the initiator sends n number of frames with different four tuples at R rate to the responder through the device under test, and the responder just counts the received frames. And of course, we don't use a multiple loss rate ratio search, but we use a zero loss testing. So if all frames arrived, then we say the test was successful, and we choose the upper half interval from the binary search if anyone, if even one less print was received and sent, then it shows a lower half interval. And this is the binary search. It determines the highest rate at which all frames result in a new connection. The problem is that we cannot prove that even if a test frame has gone through the device under test from the initiator to the responder, then it is surely resulted in an establishment of a new connection, because we may not examine directly the connection testing table because we do black box testing. So the solution is that we do a connection validation in the real test phase. It means that the responder uses all M4 tuples stored in the state table, and at a lower rate, it sends frames back to the initiator. And of course, if the corresponding connection is not there, then the frame will not arrive back. We need to use a reduced rate so that it may happen that the frame is lost just because the connection is not there, not because we are using a too high rate. So this is why we use this factor alpha, which is usually less than 1, but in some cases it can be also 1. And of course, it's just a binary search. So the initiator counts the received frames, and the binary search is done, and we do the test. Could you go to the next slide? There's some slides here. Yes. So, on the rightmost column, we can see the results with no validation. So we have 4 million connections, and we measured the rate at which the highest rate at which connections can be established. So the reference result in black rectangle is 478,000 connections per second with dual NAT6 for implementation. And then there are some results with different values for alpha from 0.8, 0.6, 0.5, and 0.25. At the first two columns, we can see some degradation, some serious degradation. It means that the trouble was that the alpha was too high. But if you see 0.5 and 0.25 for alpha, then there's practically no difference. Of course, you can see some differences because they are computers and some random events may happen. You can see the median is between the minimum and maximum values, and there's a very little difference from the reference value, but you can say that these values makes no difference. So these are the correct values for validation. And of course, we can say that even if we measured this with the real validation, it was the connections were really established, but we couldn't prove. Now we can prove it. Can you go to the next slide? And this procedure was very important because we will heavily use this procedure for the connection to table complexity measurement, which comprises of two steps. First, we do an exponential search to find the order of magnitude of the size of the connection to the table, and then we do a final binary search to find its exact value. So in some simple words, it means that we start with a safe value. Let's say we know that for sure, for another experiment, that 1 million connections can be fully stored in the connection training table. Then we double its size, and we perform validating connection establishment measurement, and we measure with the original 1 million size, and we measure it with 2 million size. And if it seriously drops, we have a we suspect that there's a problem. If it doesn't drop seriously, just a little bit, then we believe that 2 million connections were successfully stored. Of course, if it is validated, we can know it for sure that it was stored. And then we double it again, and once it will stop, and then we have an order of magnitude estimation, and then we do final binary search, which says how many connections can be really stored. So these are some factors like alpha safety factor for the validated connection establishment measurement, and there's some other values. Theta is the reducing factor for the exponential search, and gamma is the reducing factor for the final binary search. Could you go to the next slide? And I don't want to be this algorithm. It's the theoretical algorithm of the exponential search. Could you go to the next slide? Is the theoretical algorithm from the final binary search. They are theoretical because I have invented some better algorithm which has much better runtime. So could you go to the next slide, please? Yes. So all the details can be found in section 4.9 of the draft, and there's a central script which can be found at GitHub. It is a bash script which I have used for measurements. Could you go to the next slide? Here are the results. So in the first column, you see the C0 value, which is the safe value for the connection testing table size. And with that value, I measured the connection establishment rate. It was R0. And then I always doubled the sizes. And the last safe value was CS, was 4 million. And CT was when the test failed, it was 8 million. It was the result. So CS and CT were the result of the exponential search, and then the final binary search found the C result in the last column. And you can see it's very exact. So that it's a very different variations of the results. And it's quite good agreement with the theoretical value because the hash size and the NF contact max size, which means the size of connection table, was 2 to the power of 22, and we just found nearly the same value with the very few error, very little error. So can you go to the next slide? This is my final slide. And I might just have some questions that how do you think of the algorithm of the validated connection establishment rate measurement algorithm and the connection testing table measurement algorithm? And do you think that they good and reasonable? Or if you have some comments how to improve them, I'm happy to see your comments. And the question is that if you find these performance metrics satisfactory, I don't feel anything missing, but maybe you can point out something missing. And final question is, of course, that if you like it and would like to, in the working group, would like to adopt our draft, we would be very happy if so. So thank you for listening.
Okay, great. Thanks to Gabor, and thank Keiichi when you talk to him. And you guys have both been working on this, and some others as well with their comments. I noticed a comment come through in the chat. It is better to have an example picture that is based on IPv6, not IPv4. This is the comment that comes from Edward V. And Edward is one of the other, is a co-author of one of the other drafts that we're going to talk about today, I think. So what do you think about that, Gabor?
Well, to be honest, I used IP version 4 because I thought that the majority of the people still live in the IP version 4 world. So originally, this thing was done for an NAT, faithful NAT64 tester. So for me, it would be not much more natural to use IP version 6 drawing, but I just wanted to help others. This is why I used IP version 4, but I can replace it. I have the drawing, and in some paper I use both, but I will, if you want, I will replace. Shall I replace version 4 with version 6?
Well, maybe the best thing to do is have both, and that way it satisfies everybody.
Okay. I will add. Okay.
And one word of input from me, and that is be sure you use the address space that's allocated to Bmwg. But it exists both in the v4 space and the v6 space, and that way we can avoid problems with the. Supposedly, we avoid problems with the NIT checkers and stuff like that. So, just a word to the wise. There's address space allocated for benchmarking in both v4 and v6.
However, these address ranges, I use the private address range to express that it is the stateful NAT, which most people know. As they use at home, this private addresses. impression of not because I didn't know about the ranges, that I just wanted to express some information by using private IP version QSLCs.
Okay. Okay. And yeah, Edward has put in some additional comments there, identifying the /48 for Bmwg use with V6. So thank you, Ed. All right. So let's see. Oh, I see somebody at the microphone here. And the problem is I've got oh yeah, well, there's two people. So I think the first one in the queue is Thomas. Go ahead, Thomas.
Thank you very much. I just would like to briefly inform this community that I am an FPGA expert, and I recently joined to the Széchenyi University activities on this subject, in fact, Mr. Lench's team. And my project will be to implement the currently running CPERF and other softwares on FPGA environment. Sorry about this unusual demo, but I'm showing you a development board from Xilinx, what we found kind of promising because it has proper speed ports. You can see this link up here, which can link. In fact, there are 4 ports like that, 10 gig each. And it sounds like with small modification, this development board is appropriate to start to re-implement the currently running project in a different framework, which is FPGA based. And the expectation is that we are going to implement all the features what Gabor just mentioned in this presentation, and even the performance will be much higher. Unfortunately, at this point, I cannot give you any exact numbers or estimates because we are right at the beginning of this project. We are fighting with the drivers and the implementation of the DPDK features and so on. Probably within a couple of months, we can tell you much more and maybe give you a presentation about the results of this project. Thank you very much. That's all I wanted to say.
Very good. Thanks for your report, Thomas. And well, let's make sure that there's always kind of like an implementation section in the drafts that should, have some sort of reference to what you're doing there, and that makes it easy for us to find it when we're talking about the
Okay.
kind of the end game here when eventually when we get to approval. But I think that's the ultimate kind of support for the draft, that somebody's burning these things into FPGAs.
Mm-hmm. All right. Thank you.
Thank you. Okay, Timothy, I think you're next.
Hi, Tim Winters, QA Cafe. I want to answer 2 of these questions. One of them is I do think this should be a working group document. I support that. And then the second part of this is I want to review this for the metrics missing. So as part of that process, I'll take a long look at this. We do a lot of testing of stateful gateways. I'm sure there's some put some thought into this on our side. So I'll put my name down to review this draft as part of the adoption process.
Thanks very much, Tim. I appreciate you stepping forward to jump in and join us. Is this your first time with Bmwg?
No. I used to do a lot of NetSec Open. Used to work with Brian on some of that stuff. I've been a participant for some time in a variety of different ways.
Yeah. I thought I recognized you, but the picture is really small from here. So, and I see you got your V6 T-shirt on there. So thank you. Okay. Well, I think that my goal of kind of extending the working group adoption through the live meeting here has kind of been met. We've seen a number of people respond after the original adoption period closed, and of course I was one of them, and I think a total of 4 after the period closed. So and then a couple I think before it closed. So that feels to me like we're going to have enough people paying attention here for review to make this adopt this as a working group document. Anything you want to say on this topic, Sarah?
Yeah, I agree. I also am a little tardy with my replies, and I had given Gabor the feedback that I would do that today. And I agree, there's a lot of enough interest here to adopt this on list. And again, thank you, Timothy, for the extra attention you're going to put on this as well. So excited to see this move forward. Good job, y'all.
Great, thank you. Okay, so that's a good thing. Close the deck here. All right. Okay, so then our next topic up is the proposals, and now we're going to see a couple of related drafts on segment routing. The first one is on Mpls segment routing, and today Paulo Volpato will be presenting the draft. Paulo, this is your first time presenting here, so welcome to the group, and I'll bring your slides up here momentarily. Okay, I've got them.
Okay, so thank you. Good afternoon. My name is Paolo Volpato. I am with Huawei. I'm presenting this draft on behalf of the authors you see listed here. So people from Huawei and Telefonica. Luis, by the way, is sitting at the back of the room. And said by Al, it's my first appearance at the benchmarking working group, so I'm happy to be here. And hopefully this is the start of a long cooperation. So next slide, please. Okay, so just to give you a bit of the background of this draft and also of the other that my colleague Edward will present just in a few minutes. So we started from RFC 5695. So basically this is the benchmarking for an MPLS capable device. Let's say that is for pure, if I may use this word, MPLS. So there is no mention of SR MPLS, which is the topic we are interested in. So we combined, let's say, the capability of 5695 together with the architectural framework of segment routing, and specifically the SR MPLS flavor of segment routing defined by RFC 8402, trying to provide a method for benchmarking an SR MPLS capable device. So we need to, let's say, complement 5695 with some more, let's say, mechanisms, some more procedures. So that's why we provided this draft dedicated to the benchmarking of SR MPLS. And clearly, we based our work on 2544 and the newer 9004. So that is for the background. We are aware that at the moment there are no other efforts ongoing. So that's why we developed such proposal. Moving to the next slide, please.
Just a question there, Paulo. When you guys were thinking about filling this gap, was anyone asking for benchmarking of products in the segment routing space that caused you to want to do the work more formally?
I'm not sure I got properly your question. So it was about the availability in the benchmarking work group.
No, it's more like were people asking for benchmarking, to benchmark their products or testing the products without doing formal benchmarking. Did you guys recognize a need from the industry as well as a gap?
Oh, yes. The answer is definitely yes. And at least clearly, I can speak just for, let's say, the two organizations that for the moment support the draft, so Telefonica and Huawei. If you just consider Huawei as a vendor, Telefonica as an operator, we definitely think that this effort is worth our work. We are filling a gap in the industry, and that's why we are proposing such topic here. But of course, we are open to any feedback from you. As I said, I'm quite new to the work group, so probably I'm still a bit fresh to this extent. So I'm really happy to take also your feedback.
Sure. I'm really just checking on, that really we need more than a gap in the Bmwg literature to kind of get things going. And I think you've kind of answered the question that, if an operator and a supplier see the need to do this, that's a good place to start.
Sure. Okay, changes from the previous version. We presented version 01 in Vienna, so at the IETF114. We received quite a few comments, in particular from the chairs, and we thank the chairs. We acknowledge the value of those comments. Just to be very quick on my recap, we reviewed the test methodology because probably was still missing at that time, so in the first version of our draft. We also added, let's say, some more capability, I would say. So we developed new sections on the protocol addresses, the duration of a test, how to verify it. We developed further, let's say, considerations to be connected with, as I said, RFC 5695 and 2544. And by the way, we have also put references to RFC 9004 and also the work done by ETSI about the virtualization of some functions where you may also employ segment routing. And by the way, for the moment, we have decided to, let's say, leave out of the scope the transport of services on top of, let's say, in SR MPLS connection. So as you see, for the moment, we are not considering, for example, the benchmarking of a service such as a VPN, or also we need to say, for the moment, we are not considering traffic engineering based on SR-MPLS. Next slide, please.
Oh, one comment on this one. The reference to the ETSI test document, that should actually be TST 009. The test 007 is a conformance and interoperability spec, whereas test 009 comes up in the draft as getting some help for when the segment routing device under test is virtualized. And test 009, it's basically RFC 2544 for virtualized devices under test in the in the virtual machine and the containerized world. So I'll just try to set you straight on that for the moment. But please take a look at that, as I think there's a lot of good advice there.
Okay, thank you. We will correct that. Sure.
Okay, next slide.
Right. Okay, so as I mentioned, we have tried to develop further the content test setup. Well, let's say that we need to augment what is already defined by 2544, and also the let's say the base paper on MPLS. First, we have to let's see continue following the approach of having multiple ports on our device. So the packet forwarding engine may distribute packets across all the ports. We have also to take into consideration, let's say, aspects such as oversubscription. So we have to take, let's say, care of that. The idea is that the test should be bidirectional, but clearly one has the option to, let's say, to split the upstream from the downstream flows. And then, as also suggested by the chair, let's say that even if it's not full developed at the current stage, we have also to consider the availability of a virtual machine, so the softwareized version of a function handling SR-MPLS-based packets. This is for the test setup. Moving to the next slide. Okay, we have also, let's say, to consider something that it's useful for the industry. So this is one of the reasons why we see the gap at the moment for not having, let's say, a benchmarking guideline for SR-MPLS, and as I said, also SRv6 later explained by Edward. So for running the test, we need to, let's say, choose a protocol for label distribution. So we have provided a list for test that could be IGP, BGP, or other ways to, let's say, distribute the policies. Differently from 5695, we will consider more than one label. And the reason is that, let's say, otherwise we are not fully exploiting the capability of SR-MPLS. It is true, to do so, we should have in mind, let's say, a service, but for being ready to support all the capabilities supported by SR-MPLS, the idea is to have at least 2 labels corresponding to 2 seeds, 2 segment identifiers, such that the outer label will be in the future considered as the entry point for carrying a service, as I said. And then we have also to, let's say, deal with the MTU of the packet. Clearly, we need to consider 4 bytes per label. So that's why, as you see here, we have to add at least 5 bytes more to the packet, because differently from the base MPLS, we have 2 seeds, so 2 labels, so basically 8 bytes for the label stack.
It's good to calculate or to catalog these differences from 5695 and why you've had to make these choices. That's excellent material. Please continue. Sorry for the interruption.
Okay, thanks. So moving to the next slide, please. Clearly, we have also to think about how to provide the result of the test. So for the reporting format, new parameters have to be considered. You see the full list. So just to, let's say, going very quickly through the items, the number of ports we are using for the test. As I said, we need to consider the full capability of a packet forwarding entry and maybe also over the subscription. The possible differences between upstream and downstream, so the proportion of the traffic we split between the two. What types of SR-MPLS operation we are dealing with? Probably you are already aware, SR-MPLS is based on 3 operations: push, next, continue. We will discuss in the next slide, but just to anticipate the topic, basically they are corresponding to the different operations supported today by base MPLS with some, let's say, differences. The number of labels, so the depth of the protocol of the label stack. So as I said, at least 2 seeds, 2 labels. How we instruct the device to build the label stack. So we need to also take care of the policy that should be considered within the framework of the test, the type of the payload, the protocol used for label distribution, and clearly, if there is maybe somebody interested with that, we take for granted that we are using just Ethernet connectivity, but in case other, let's say, media formats can also be used. I will say next slide, unless there are questions here. And as I said, SR-MPLS is based on 3 fundamental operations. The push operation is corresponding, as the name implies, to the label push. So basically, we instruct the device of putting in front of the packet a couple of labels. So to let's say, place as the overhead of the packet a label stack. The next correspond to the label pop, so as it happens in base MPLS today. And then the continue, which is, let's say, the equivalent of the label swap. Clearly, we have to take care of the specific differences with, let's say, the normal behavior of SR-MPLS. And this should be also reported in the result of the test to be coherent. Clearly, more, let's say, more information can be found in RFC 8402, the basic architecture of SR-MPLS. And I would say that's it. So we can move to the next slide, which is our conclusion. Basically, we'd like to, let's say, listen from you. If there is interest in working on such item. So when we say if the benchmarking work group is happy to consider the adoption of this, let's say, of this paper, it's not just to the formal adoption of the draft, but to see whether there is consensus in moving on with having a paper specifically devoted to SR-MPLS. Any input, any feedback is really appreciated. And by the way, we are also open to cooperation. If anyone wishes to join us as co-author, there is this possibility. And I would say this is it for now. Thank you.
Very good. Thank you. So, Paulo, you've asked the right questions here. The we really need some folks in BMWG to step up and basically to say, I've read the draft, it's a decent draft, and provide some comments. But first thing I'll say is it was really good to see how your draft improved from the current version, from the last version. You really stepped up to adopt the the material that was available in the BMWG literature, and that was a great improvement. So thanks for doing that. That was based on the comments from last time around. So does anybody volunteer to review the draft today? Or, review the draft for the future? I see a request from Boris.
Hi, Al. Yes. So I recently tested SR policy with different vendors, so I can review this section and provide feedback a bit later after IETF.
That's great. Thanks very much.
Thank you, Boris.
Okay. Anybody else? All right. Well, that sounds like pretty knowledgeable feedback today, Paulo. So maybe when Boris posts his comments, it'll draw the interest of others as well. So thank you to your co-authors and contributors here for a nice piece of work.
Thank you.
All right. So now I see. Now I think I see Edward joining us by video. Is that correct? Yes.
Yes.
Welcome, Ed.
Good day, everybody. About our second slide deck, because the same people have developed the same two drafts. For that reason, the style is the same, the scope is the same, but the technology is a little bit different. For that reason, the text is a little bit different because SRv6 is a little bit different from SR-Mpls. I would like for start to answer a question from our chair about is it really important? I could prove that for SR-Mpls it's even too late. Why I believe it's even late? Because look, about a few thousands, maybe 2.5 thousands of telco already has moved from old style MPLS to SR-Mpls, and for telco world it's typically important and it's typically mandatory to test any new technology before adoption. And for that reason, already about 2.5 thousands of tests for SR-Mpls did happen. And it means that we are a little bit late with our test plan. For a SRv6 situation is not so urgent. It's a little bit better because for SRv6 we know that worldwide already 250, something like 250 projects in development. So some projects already in production state. Some projects are still in test and preparation, but it's 250, and 250 tests already has been done for SRv6. It probably means that 250 tests are already done worldwide. It probably means that we need a test plan. We need a benchmark methodology to explain how to do properly this test plan. And for that reason, it's probably a good evidence that if 250 tests already has been done, probably should be the discussion in IETF about how to do it properly. Next slide, please.
Thanks for that perspective, Edward.
Okay. about the basement here. The basement here is a little bit different because, of course, the primary basement is our primary benchmark RFC 2544. Of course, it's really a primary one. But additionally, because Service 6 is IPv6, we need to take care for RFC 5180 for IPv6 benchmark methodology. But in reality, because it's in behavior of Service 6 like behavior as Mpls, in reality, we need to inherit many things from Mpls benchmarking, from RFC 5695. Therefore, it's a mix. There are some number of things which are unique for Service 6, but in fact, it's a mix of combination of things which is taken from IPv6 and which is taken from Mpls benchmarking. This is a little bit different from the previous one, Mpls one, which is more or less simpler from that point of view. Next slide, please. We have excluded from the consideration because from our point of view, the methodology is already more or less big. I mean, draft is more or less big. And looking to the other drafts which we have seen for benchmark working group, we have decided that probably it's enough. Probably we have big enough scope, and we have excluded from the scope traffic engineering, and we have excluded, of course, services, VPN services, for example, because then the draft would be extremely big. And as we have seen before from benchmark working group, typically such things as traffic engineering and services were in separate document, and for that reason we follow the typical style of benchmark working group. From the previous version, we could say that we have changed, like for Mpls here is the same. We have changed something like, from my point of view, 40% of text has been changed. We really did a major change. If somebody has read it before, forget about it and read again, because we have really changed a lot. Next slide, please. Okay, what is really maybe new here, maybe different from Mpls and IPv6 benchmarking? As for all other benchmarking RFC, we assume that configuration of label stack or seed stack here will be automatic, will be by some protocol, ISIS or SPF, or maybe segment routing policy, which is effectively BGP or PCP. We assume that it's not manual configuration. Of course, it's possible manual. We permit it as an option, but we recommend that it should look like a real situation, should look like a real protocol will populate prop tables. Like for previous SRMPLS, here for Service6, of course, we are trying to ask that recommended way to insert at least two seeds, at least stack from two seed, because if it's just one seed, it's not a stack. It looks not reasonable. But here there is a big difference between the Service6 and SRMPLS, because in SRMPLS, every label, every seed, every label, MPLS label will give you just one hop or one interface. It's really one next hop, one next interface. In SRv6 case, it could be two, because in SRv6 the seed could be split for three parts, and first part is a node, next part is a function. The last part argument is not important right now, but the first part could be the node, and it's already the instruction where to forward. But after the node part, inside the same seed could be the part which is responsible for so-called function. And sometimes function, especially for traffic engineering, could have name end.x, for example. And if it's end.x, it's effectively the number, it's next hop interface number. It's effectively next interface. And then it means that effectively one seed has two instructions, one how to reach the node and one how to go out of this node on the next hop. And because it's not related to services, it's related to infrastructure, we have decided, despite that it is a little bit traffic engineering, it's used for traffic engineering, we have decided to include it in the consideration. We have included it in the discussion. It's a little bit disputable because look, it's not services, okay, it's fine, but it's for traffic engineering in the future. But we have included this because without this, it's not proper test from our point of view of SRv6. Of course, we have corrected header size, MTU and header sizes, because here we have additional headers, 8 bytes for SRH header itself, and additional 16 bytes for every seed for every IPv6 address, which is inserted in inside. And if people would like to test more than 2 seed, for example, it's optional, but it's possible. Then the header could be big, and we have calculated properly and put recommendation about this point that the size is different. Okay, go next. Okay, of course, because we have included here a little bit additional discussion about upstream downstream proportion, about relationship between port numbers and PFE, because look, in the current world, there is no one-to-one relationship between port, device port, device under test port, and PFE. Typically, one PFE is capable to serve a few ports. And to really test something on modern box, you need to really test all ports related to one PFE. You really need to stress one PFE, because the PFE is very flexible. If you will stress just one port, the PFE will throw to you much more buffers. You will test wrong numbers, because you will get much better latency, much better performance than it's possible for load when all PFE ports are loaded. And for that reason, we have a discussion inside that, okay, we have a discussion how to understand what is the relationship between ports and PFE, because in fact, you need to stress not port, you need to stress PFE. And after you will stress PFE, of course, you need to document which one particular port has been used. The same discussion about upstream, downstream, like before. And here we have a little bit, again, different names, which is used for SRv6 operations. For that reason, it has been reflected in the document. And of course, number of seeds, how big seed stack should be documented, of course, and what particular protocol has been used to populate seed stack is, of course, should be discussed. And for that reason, the reporting points a little bit extended, because it's like for SR Mpls, more points to mention. Next slide, please. For SRv6, the terminology again has changed a little bit. It's very similar to what we have for MPLS, but a little bit different. Here we have so-called source node, which really create a seed stack and IDD SRH header. Okay, fine. Then we have endpoint node. Endpoint in reality is not final end. It's intermediate endpoint, I would say, because what it means that this endpoint will change the destination address, will copy address from top of from the pointer of SRH and change the pointer to next one. It's effectively like swap operation, but there is no here swap operation, because in the middle we don't change headers. We just change destination address and we change entry point in the SRH stack. And transit node. Transit node is something new, not present is SRMPLS, because transit node is a just ordinary IPv6 node, which may not understand SRv6 at all. It's just IPv6. And transit node just look to destination address and forward. The only thing which is important for transit node, not to drop the packet which has bigger headers or bigger MTU, or because additionally SRH header is attached, and transit node just should not pay any attention to this SRH header, routing header, because transit node is not destination for this particular SRH. But anyway, it should be tested, because performance may be affected, additional header, extension header, performance may be affected, everything may be affected. For the reason it should be tested. Okay, probably that's it. Next slide. Okay, because we really spent more or less big amount of time and we did everything possible. We have changed a lot the draft. In reality, we don't have any more idea what to ADD. we have investigated all potentially related RFC from benchmark working group and all potentially related RFC and drafts from Spring working group and a few other related working groups to understand the full picture, not to miss anything, not to miss some important things. But after such investigation, we have populated everything in the draft, and now we don't have an idea how to improve it better. And for that reason, any input is very welcome, and maybe it's a time for adoption because in general it's needed. I mean, the problem exists, and because the problem exists, the text, of course, could be discussed. Of course, if somebody believes that somebody should be changed, of course, we will change it. No question. But it looks like we did everything possible. At least 4 people who really participated in this.
So thank you, Edward. Let me ask a follow-up to your final response there. Have you done any testing with the procedures that you've currently outlined in the draft?
Not exactly for this one, but I have participated in a couple of tests of SRv6, but because typically different telco, different carriers, they have different requirements, what they would like to test, and for that reason, it's not exactly the same. The similarity maybe 40 or 50%. This one is more or less general, and in particular situation, people would like to know particular things. For that reason, I would not say exactly the same, but maybe 50%.
Okay, so maybe one of the things we could encourage is for people to try out this version of testing, and that will reveal the areas for additional development that they're looking at. And then, of course, anybody is welcome to read this and provide comments based on their previous testing experience. So there's really 2 sources where we might get the inputs that you're looking for. So let me open it up to the floor now. Is anyone willing to sort of try this draft out in on the test bench, or is anybody willing to just review it and provide comments? Okay, Luis, please go ahead.
Yes, hello. So, well, I'm co-author of the draft. We are planning some testing after the summer in Europe. And to be honest, by now, we don't have yet a clear mapping of what we can do from the draft to the testing. But well, the idea or the commitment that I comment here will be to try to match what we will do with what is in the draft and report probably coming back for IETF114, reporting what we did and to what extent we use the content of the draft on that testing that will be done in the lab. Okay.
Very good. Thanks, Luis.
Thank you.
And Gabor.
Yes, thank you. I would like to read the draft, but please give me, let's say, 2 months, because I'm very busy now. I would like to read and comment the draft on the mailing list.
Thanks.
Yeah, it's summertime. Everybody gets to take August off if they want to. So thank you for volunteering today, Gabor. Anybody else? Boris, go ahead.
Yes, same as Gabor. Also, after Mpls, I will look also to this draft.
Thank you. All right, well, I think we've been able to get you some good potential reviews, Edward, and the team. So, oh, and I see somebody else at the microphone there.
Hi. I was wondering if there was any current examples of like someone testing this, what's outlined in the RFC draft. Thanks.
And what was your name? I'm sorry.
Christine.
Christine, okay. Go ahead there, Edward.
I not fully understand the question because it's more or less a new draft, and exactly this draft has not been tested, but the people who developed this draft has experience before for many other different tests, and for that reason we just use our knowledge about SR-MPLS, SR-VSX, and we have used our knowledge about test itself, because test itself has been done many times for different things, and we have created a new draft, and this exactly new draft has never been tested. Therefore, I don't understand the question.
I was asking if the current draft had been tested. So.
No, exactly this one, no, has not been tested.
Thanks.
Okay. Any other questions? All right. Well, thank you, Edward, and the co-authors again for your excellent work here. Much appreciated, and thanks everyone for contributing to the discussion. And yeah, Boris. Okay, I got that one in there too. Good. Okay, so let me I'll close this deck. I'll share my screen here. I still want to do it. I want to do screen one. All right. All right. So I just wanted to mention a couple of items under all other business. Couple of meetings, actually, like 2 meetings ago, we talked about problems and requirements for benchmarking the LEO, low Earth orbit space technologies and connections with terrestrial networks. The authors did not request a spot at this meeting, but they updated the draft back in April. And I think that kind of reflects the fact that there's a lot of interest in the low Earth orbit satellite communications. Many people probably know that Elon Musk's company has been launching satellites like crazy. They're aiming for, really large constellation. And right now the constellations are fairly simple in terms of what satellite processing does. But that will likely change over time. So there's some interesting feedback to give here if you're involved in this work. And also the considerations for benchmarking network performance in containerized infrastructures. That team, really both these author teams are in the Far East. So this is like the absolute worst time zone for them. And so they can be forgiven for not trying to come in and do a live presentation this time. But the virtualized performance or containerized performance team participated in the hackathon. And they were doing some very interesting work on express data path and the the Berkeley packet forwarding that the new kernel Express Data Path XTP makes possible. So I encourage you to take a look at that, and I'm going to follow up with them to basically to try to get them to share some stuff on our mailing list, so we can show, so we can see the advancement of this work, and everybody should take a look at that if you have interest in this containerized infrastructures. Oh yeah, also Ed, since we're on the topic of virtualized benchmarking, same comment to you. It's test 009, not test 007. It's basically the same draft that has the real material that you want to reference in the SRv6 draft. Okay, so that's good. All right. Any other business before we close up here this afternoon? All right. Well, thanks for a really good meeting. I think that we've heard from a lot of drafts under development here, and we've heard from a lot of drafts that are nearing the end of the road, and drafts that are successfully joining the working group as part of our ongoing work. So really appreciate everybody's contributions today. Appreciate Warren for standing in for us up front and letting us know what it's like to do his job, and to everybody for your attention this afternoon. Anything to add, Sarah?
A big plus one as usual. You do a great job with that, Al. And yes, thank you, Warren, for stepping in and helping us on site, and everybody for making this move. It works so smoothly in such a hybrid environment. It's nice to see folks on camera. It'll be really nice to see you guys in person soon. Thanks for a good meeting, y'all.
Hey, you're welcome. And I hope to see everybody in London. After this, I feel like they owe me one. I was going to go until last week from Monday, and things changed too fast. So apologies about not being able to make it, but I should have a better voice by London too. We'll see. Okay, everybody. Happy trails, safe travels, and talk to you soon.
Take care.
Thank you very much, everyone.